In this dataset, we have 3,071 households, and we've calculated a sample size of 600. Based on the constraints of the program has decided to survey 30 households in 20 villages. For the first stage of the selection, our sampling frame will be all villages, and the second stage will be all households within those villages. So on this spreadsheet, we see a list of all villages or clusters, which we'll use for our first stage. And on this spreadsheet, we have a list of all households that we'll use for our second stage. These are the households we'll eventually survey. In the first stage of selection, the program has determined it makes sense to use probability proportional to size sampling to ensure that villages with more households have a greater chance of being selected compared to villages with fewer households. As mentioned, the program has determined they want to sample 20 villages and then 30 households in each village. Looking through our sampling frame for the first stage, we notice that some of the villages have fewer than 30 households. If these villages are selected, we won't have enough households to draw for our sample in our second stage. When this happens, one way to address this issue is to remove these villages altogether from your sample. But if you have many small villages, this can risk biasing your sample. To determine whether it's appropriate to remove the small villages, in this case, those with under 30 households, we want to look at what proportion of our sampling frame these villages account for. To do so, we'll add the number of households in our villages with fewer than 30 households and divide that sum by the total number of households in our sampling frame. We can easily find the villages with 30 or fewer households by sorting the number of households column from low to high. We see now that villages 16, 20, 22, and 35 have fewer than 30 households, and the sum of households in these villages is 71. Dividing this number by the total number of households in our sampling frame, which we saw on our other spreadsheet is 3,071, we see that these households account for about 2.3% of our total households. If the proportion is under 3%, like it is here, we can remove these villages without biasing our sample. If the households in the small villages were to have accounted for greater than 3%, the total number of households in our sampling frame, we would combine the small villages with adjacent villages when we draw our sample. Some more details around combining adjacent villages is included in the description following this video. Now we're ready to draw our first stage sample. As demonstrated in the probability proportional to size demo, our first step is calculating the total number of households. We'll fill out the cumulative number of households in this column here. Village 1 has 115 households, so the cumulative number in this row is 115. Village 2 has 60 households, so the cumulative number is 60 plus the previous cumulative number. The cumulative total in the next row will be the sum of villages 1, 2, and 3. We'll continue to fill out the cumulative column here for the rest of the villages. We can see after removing the villages with fewer than 30 households, our cumulative number of households is now 3,000. Next, we'll determine the sampling interval by dividing the total number of households in our sampling frame, 3,000, by the number of villages we want to sample, 20. Our sampling interval is 150. Next, we will generate a random start between 1 and our sampling interval, which we just determined to be 150. We can do this by using equal sign rand between 1, comma 150, as shown here. The number generated is 26. I'm going to recopy that number now so that the formula does not continue to generate new numbers. So 26 is our random start number. We can see looking at the cumulative column that village 1 contains the 26th household. This village contains households 1 through 115. So village 1 will be the first sampled village. We'll then select the next village to be sampled by incrementally increasing the random start by the sampling interval. So the random start, 26, plus the sampling interval, 150, is 176. Again, looking at our cumulative column, we see that village 3 contains the 176th household. Village 3 contains households 176 through 220. We'll now take this number, 176, and add our sampling interval, 150 again, to get 326. Village 6 contains our 326th household. We will continue sampling villages incrementally like this until the desired number of villages has been selected. In drawing our villages, we noticed that some might be selected twice. For example, we can see here that the 2,576th household and the 2,726th household both fall within village 40. In that case, we'll denote that in our sampling frame, and we'll draw twice as many households from that village in our second stage sample.